So we'll be going over that introduction down the talk. Today's talk is going to be a little hodgepodge. We'll be looking at stuff at DevOps. We'll be touching upon data science. We'll be touching, of course, on the Python programming language. And to cap things off, we'll even touch upon components in the web development world. So it's kind of going to be an array of technologies that we're going to cover throughout the talk. And I really hope I make a lot of sense, because ultimately the point is to leverage all these pieces of in situ technologies to stitch together an application that makes a lot of business sense. Yeah? So with that, I'd really not be justifying a decent kickoff to this event if I'm not introducing the world of Python. So what is Python really? And why is it that a programming language that has seen the course of 3 decades is suddenly emerging into popularity over the past 5 years? Why is that? It may seem a little exaggerated, but it is true. While 10 lines of Python script may not eliminate 5 jobs per se, but it does have a pretty strong use case in automations, and they are actually responsible for replacing a lot of blue-collar jobs, as we call it. So definitely businesses love Python, and businesses love Python programmers. Over to the developers side. Why do the developers love Python so much then? Everyone in some point in their career has done some C programming, am I right? And for that matter, we'll keep the talk a little interactive so that I don't want this to be a one-way lecture. Okay, so let's keep this interactive. So I believe someone, at least most of you, have done some C programming, right? Yeah. And your typical programming is about swapping two variables in C, A to B, B to C, and whatnot. How many lines of code does it take approximately to do it in C? And Python? Okay. So I guess you already know about that, right? And to really cap things off, it's a high-level programming language. So for all of those who can't read there, it is above sea level. Okay? So Python is above sea level. Now, just as we were talking about the technologies, I just want to formally list out the kind of technologies or the kind of business problems that can be solved using this programming language alone. So I'm not talking about using a bunch of programming language along with Python, but I'm saying Python alone can do all of this full scale, production grade. Okay? So the first is web development. Give me a couple of names of the web development frameworks. Flask? Django? Yeah? So anyone who has used Flask or Django, they'll know what I'm talking about, right? So it's an end-to-end web development framework that I already have with me in Python. The next part, businesses love it. Workflow automations, all of it can be done using Python and are being done using Python, right? Educators love Python. So any professor out there, chances are he'll be using the Python programming language to implement stuff, right? Because it's so easy to use. Okay? Next comes software developers. So I've been a software developer in my career. I know the importance of Python. I know the importance of rapid development. I know the importance of sticking to timelines, and I want a programming language that gives me the ease of use so that 20 lines of code can be reduced in 5 lines, can be reduced with ease, has some significant similarities with pseudocode, and I can deliver stuff fast, still optimized, right? But the top of the food chain over here is really this thing, isn't it? This thing is taking the world over storm, data science. Who has got some or a lot of ideas about what is data science, machine learning, AI, and I'll use these terms interchangeably. So I hope you guys have heard of it at least. Show of hands, please. Oh, brilliant. Okay. So most of my audience has already heard it. Good to begin with. So now, having introduced the world of Python and the possibilities that it can offer, we'll move over to the center point of this talk. The topic being deploying machine learning apps using Docker containers. So it really starts from a data scientist who has built a model. Okay? Again, show of hands, who has built a data science, machine learning, AI model, so to speak, using Jupyter Notebook or R or SAS or any technology for that matter. So a model is basically an equation that is used for predicting future data. Okay, as simple as that. So data scientists, they are on the process of using the data that has happened in the past to build a model that can predict the future. Okay, so this basically is it. The data science in a crux is basically building models. 90% of it is building models, be it deep learning models or something as simple as linear regression models. It's all about building models. I'm here to talk about the step to take after you've built the model. Okay? So here you see a picture of a container getting shipped, and this is not just any container. This is a very standard container that we have in the shipping industry. Right? So before this, if you have to transport goods in a ship, you will have to, maybe the fishermen will bring in a plethora of fishes. There will be hairpin manufacturers looking to transport stuff. Oil needs to be transported, and all of that, they come in various sizes and shapes with no standardization whatsoever. But with the advent of containers, it all became standardized, wherein you put all your goods in a container, and the container goes and sits on the ship, wherein you'll be able to do space allocation inside the ship in a much smarter way. Okay? So, I think I've already talked about some of this stuff, and I've had a show of hands already, but I'll just formally introduce some of the skills that I'm looking for as a prerequisite to this talk. So I want you guys to have at least knowledge of one programming language. Along with it, some basic machine learning skills will really help us set the context here. And of course, any learning takes some passion to understand, right? What I'm not looking for is Unix expertise. So whenever the term deployment comes to mind, it's always working with Linux-based systems or Unix-based systems, and I really don't want you to have a Unix background, right? So to attend this talk, for that matter. Expertise in Docker, well, I'm here to introduce the concept, so definitely even if you've never heard of Docker, that's fine, okay? A complete beginner level is fine by me. And of course, you need to know nothing about advanced DevOps and machine learning. That's not the center point of this talk. Even if you build a very simple machine learning model, I'm here to introduce to you the different ways in which you can deploy those models in production, right? So are we good with this? Any questions? And for that matter, if you do have any questions, feel free to interrupt me, okay? Thanks. So we come back to the question. I have a machine learning model. Now what? So usually what happens is, when a data scientist works on a model and has successfully built the model, the new data that comes to him in an email in the form of an Excel file, and he actually has to load that Excel file manually, do the predictions, get the output file, and then send an email back to his business stakeholders saying, here are the predictions. And he'll do it on a day-to-day basis. He'll probably do it on a weekly basis. He may even do it on a monthly basis. But all in all, once a model is built, there's a lot of manual intervention that comes along the way that we want to avoid using these pieces of technologies, right? So ultimately, what you want to do is you want to build a web service out of your machine learning model so that that is deployable in a Linux-based environment or in some production-grade server infrastructure that you're already sitting on, so that the different clients, maybe from a desktop or from a mobile app, can leverage this web service and get the intelligence out. Okay? You might want to incorporate your model in an existing software. So you see that, okay, are there any Android 1.0 users here who have seen Android 1.0? Okay, they'll know it. The Google app that was there was actually very minimalistic, right? So anything you search, there were no suggestions, there was no instant search, there were no recommendations, there was no spelling correction, there was literally nothing. It was just bare bones, a wireframe of the Google app that we see as of today, right? But over time, it has smartened up. And how has that achieved that piece of architectures? Through microservices, right? So every bit and piece of intelligence that you see in the Google app right now is actually a separate module under development, is a separate module under deployment, is a separate module under maintenance, okay? So we live in the world of microservices, and any microservice that you're going to build has to go sit on some bigger piece of software, okay? The business user will ultimately see the big software, not your microservices. And of course, we have big use cases in automation. So automation is a big use case when it comes to Python, when it comes to data science, AI, machine learning, all of it. Okay? So the goals for today will be introduction to Docker containers, deploying machine learning solutions using Docker containers. We'll actually try to deploy 2 instances of 2 separate applications altogether, but on the interest of time, we may restrict that to 1, okay? But I'll try my best to show you 2. So deploying machine learning solutions using Docker containers, building and deploying robust machine learning services. So obviously, we will talk about some of the machine learning, and any and all of the machine learning that we are going to build will be based on Python. So again, that center comes back. By the end of this talk, I hope you will have a solid foundation on using machine learning applications in a deployment environment. Okay? Now, having said that context, any questions till now? Silence means either means good news or something's not going right. Are we okay with this? Okay. Just feel free to interrupt me anytime you see there's a gap, okay? So why these Dockers? Basically, they have a premise when they come to the IT industry. And some of it are like this. You build once, you deploy everywhere. Who as a software programmer in this room has had a problem saying, okay, it was working on my laptop, but it's not working on his. I think there's some firmware missing, some software missing. It was working on his laptop, but now I'm trying to demo it over here. It's not working now. Something is going wrong. Some installation is missing. Some software is missing. Some bug introduced because of some operating system change that happened. Maybe you're trying to switch software from a Macintosh to a Windows, and you suddenly see things break. Things are just not working. You scramble over Google for a couple of days. You literally crawl Stack Overflow, and then finally in some dark, deep corner, you find the answer, only to know that if you had used Docker containers in the first place, you could have avoided all of that altogether, right? Now think of the business setting. Whatever we are dealing with at this level is actually 100 times amplified at a business level. Every hour that a business is down, a billion-dollar company actually suffers millions of dollars in losses, and it can't afford to have its system down. So we need to build robust systems wherein we ensure that the applications that are live, they stay live, they don't die, or there is no downtime, so to speak of. Have you ever seen Google down? Google.com, and then suddenly you feel like unable to connect to server. Has anyone experienced this before? Last I experienced this was, I guess, in 2003 or something. So they've been live for more than 10 years. And they give very good metrics on around 1 million seconds or so. They've been live, totally live. They've never gone down. And that's the kind of contingency you want to leverage in a business setting, right? So with that in mind, we want to build once, but we want to deploy it everywhere. We want to deploy in our development environment, on our test environment, on our production environment, and we don't want that to go down, right? So we want some standardization when it comes to the infrastructure on which our software will sit on, okay? Resources are isolated. So when I say resources are isolated, I'll be able to better show you once we hit the demo section. But mostly what I mean is, have you ever encountered softwares messing with each other? So let's say Elasticsearch 4.0 requires Java JDK 7.0, and then you're probably running a Hadoop cluster which wants JDK 6.0. So now you basically have 2 JDKs in your system, JDK 7, JDK 6, and they clash because the operating system does not know which one's configuration to pull out, and it becomes a very messy architecture, right? When softwares clash, bad things happen, very bad things happen, and we never want that to happen, right? So we want every piece of software that has some subsequent dependencies on it or has some cascading dependency on it to be separate and some other application that is using the same version, or sorry, the same software with a different version, we want that to be separate. Okay? So we want resources to be isolated. We want them to talk to each other, but we want them on separate environments. We want them on separate containers altogether. Okay? And of course, we bring about a lot of environment standardization as we go along. Hence, we need Dockers. So usually when I'm trying to justify a new technology, I start with why. And these are the 3 main points to answer the question why. So any questions with the why Docker thing? Convinced with the fact that we do need Dockers? Yes? Okay, a murmur of agreement should be enough for me to go forward. So we've established the fact why Dockers. And now we come over to the what part. Okay? So before the era of Docker containers, and I'm sure many of you will know this, we lived in the world of virtual machines. Who all know what are virtual machines, or who all have used them? Most of you guys know what are virtual machines, right? So to introduce Docker in a very formal way, I need to take a step back and revise what virtual machines actually do and why Dockers are a step forward from there. Okay? So we have a typical server. What physical resources does a server have? Essentially, it has a CPU, it has RAM, it has storage, and of course, it has its own network. Now, these are the 4 main components of a typical server. Now, if I push this stack down, introduce a layer of hypervisor on top of it, I'll be able to build virtual machines on top of my single server. So whenever you guys have started a virtual machine in your laptop is the server with all its CPU, RAM, storage, and network resources. There is a hypervisor that needs to be installed on top of your server. And then once the hypervisor is built, you can actually start virtual machines on top of your server. So a typical VM will pull physical resources out of this server. Namely, it will take a piece of the CPU, it will take a piece of the RAM, it will take a piece of the storage, and it will take a piece of the networking as well, right? So let's say 100% constitutes a server, and we have one VM consuming 25% of all these resources, okay? So the CPU, 25% of the server, RAM, 25% of the main RAM, server RAM, storage, and network. All of it, not the network, but the storage, all of it gets consumed 25%. So I introduce another VM, and another one, and another one. So I've basically exhausted all my compute resources, right? So typically, if I use 25% of the physical resources in my computer, I can only fire up 4 virtual machines. Am I right? Right. So what is it with these virtual machines that are becoming problematic? These provide isolations as well. So every virtual machine, they are actually environments in themselves. So basically, if I'm deploying software into virtual machine 1, it has got nothing to do with the deployed software in virtual machine 2. Okay? So these environments are isolated, but the problem is, what if the first virtual machine is not getting utilized properly? Let's say 1% of the first virtual machine is getting utilized, and the second virtual machine needs a lot more space than the first virtual machine. Then what do we have to do? We'll have to manually switch back some storage allocations, and we'll have to live with those switchings over and over and over again. So basically, we are playing things at a physical resource level, and we take those physical resources available in my server, and we distribute them across virtual machines. That's the pretext. The problem is, whenever I allocate resources to a virtual machine, if I have to deallocate some stuff, let's say I'll have to pull 10 gigabytes of space from virtual machine 1 and allocate that to virtual machine 2. The problem is, I will have to switch off virtual machine 1, switch off virtual machine 2, switch the configurations, and then switch them on. which again poses a problem because being live is the only business setting that we want as a constant, right? So introducing Dockers. While virtual machines concentrate on the physical resources, physical, right? Your RAM, your storage, your network, your CPU, Dockers leverage the operating system as a resource. It has got nothing to do with your hardware. It's a software on top of your operating system. So basically, it will have its own PID1 process. It will have its own network stack. And it will have its own root file system. Okay? So what is it that we see different in Dockers from virtual machines? Dockers are on top of operating systems. So they are operating systems inside operating systems, right? But virtual machines, they are pulling physical resources out of the computer, which I don't want. So now, if I decide to start 4 Docker containers on top of this server, all 4 can remain unutilized, and I can decide to switch on a 5th Docker container if I want to, right? It can be that Docker container 1 requires 30% of resources, then it can go take 30% of the resources from the operating system. And we know how good a manager of resources the operating system is. The operating system has been a matured 30-year technology when it comes to managing physical resources inside a computer. So we trust the operating system, and Docker is just a software deployed on top of an operating system, asking us to manage all the physical resources that are underneath, right? So instead of grabbing the physical resources from underneath, we rely on the operating system on top to actually grab all these resources for us. Okay, so we've talked a lot about infrastructural stuff, actually. We weren't talking anything about Python. We weren't talking to machine learning or anything for that matter. So now we'll come back to this side of the talk, and we'll start talking about how these Dockers can help us do machine learning better. Okay? So first is, use the libraries with complicated setup process. Yes, please.
How are Dockers exactly applying like resource isolation because they are relying on operating system?
Right, so that's a brilliant question. The question is, they are software on top of the operating system, so how can they provide isolation at the physical resources level? Well, the thing is, they don't provide isolation at the physical resources level. They provide isolation at the software level, right? So if you have 4 Docker containers on top of your operating system, they talk to the operating system. They don't talk to the physical resources directly. So basically, they are isolated environments that can grab onto physical resources as and when required. Okay? So they're not virtual machines locking onto your physical resources. A Docker container can go in 0% utilization as well. It can also go up to 100% utilization of the servers. Does that answer the question? Brilliant. Okay. Yes?
So how is the Docker container different from a Python virtual environment?
Okay. The Python virtual environment is basically Pythonic software that provides you isolation. What if you want more isolation? So right now, I want Apache Spark 2.0, Python 3.6, and Hadoop 2.7 in one environment, okay? And probably I'll use PySpark there, right? In a different environment, I want Python 2.7, right? I want Django, I want Apache HTTP, and for all that matter, make up a bunch of other software and put it there, which is not very compatible with this side of the environment. So how can you isolate them using virtual environments? So when it comes to pure play Python, it's a very good deal to use virtual environments. But when it comes to packaging a bundled software, it's actually essential that we use Docker containers, right? And one more thing, when you come up with a virtual environment in your machine, it's actually very difficult to export that to someone else's machine, right? So although you're isolating resources inside your computer, whatever that you're doing in your virtual environment is not very replicable inside some other user's computer, right? So I'm here to say that once you build something Docker in your machine, you can just pass that parcel out and replicate that environment over here effortlessly. Does that help? Okay, great. So use libraries with complicated setup process. So when I say complicated setup process, I don't mean complicated as such, but I do mean softwares that don't talk to each other very well. Okay? So in a Windows environment, all the deep learning heads, all the deep learning crazy people will know that you need Python 3.x to run TensorFlow in Windows, right? But TensorFlow can run in Python 2.x in a Macintosh. So there's a lot of incompatibilities when it comes to running software environments, and we definitely want all these libraries and setup processes packaged in an environment that is isolated and that is portable. Okay? So that's my first premise to doing machine learning. So in one particular data science setup, I'll be using XGBoost. In another, I'll be using TensorFlow. In another, maybe I'll be using PyTorch. In another, I'll be using CNTK with Keras. Impossible to shout above that, so I'm sorry. So using libraries with complicated setup, and especially where they can't talk to each other, we'll definitely use Docker containers, right? So we'll fire up a Docker container for TensorFlow, do our TensorFlow stuff there, and just shove it aside. We'll use another container for our XGBoost, do some stuff, package it aside. That's how we'll proceed. I think he has already asked me the question where he wanted to know the advantages of using Docker containers over virtual environments in Python. That's mainly going over reproducibility of the environment, reproducibility of the output, right? So I have seen instances where random number generation is different in a Macintosh than a Windows. Because ultimately, NumPy at its core is using the C language, which is compiled using assembly language, and assembly language is different when it comes to operating system level resources. Am I right? Right, so when you want to reproduce output, you want these Docker containers, right? And anyone who is a little familiar with machine learning will know how important random number generation is, and he'll know how important the reproducibility of the output is, right? So when you're playing a Kaggle competition, you got 99% accuracy, you run the algorithm again, it shoots down to 97. Don't want that to happen, ever, right? So, anyone knows what a Swiss knife is? It's a kind of depiction of that. So basically, when you fold all of these parts that are coming out of the Swiss knife, it becomes portable. It becomes one single device that you can put it in your pocket and carry it. If you start pulling up stuff, you'll get a knife, you'll get a nail cutter, you'll get an opener, and what all? All of these resources are isolated and they are portable. So that's the kind of iconic depiction, or rather my version of iconically depicting what is isolation and portability, right? Who here plays Kaggle? Has heard of Kaggle? Brilliant. Okay, so Kaggle is actually a platform where we go in, we'll have some competitions, and we can literally enter into any competition that we want. It's mostly a data science competition. I think all of it are data science competitions. So typically you'll have some data, you'll have to download the data, write some scripts, and you can actually choose to write Kaggle scripts inside Kaggle.com, and they will run. So what do these Kaggle machines use when they're trying to run all of these scripts? So think of 10,000 data scientists simultaneously running code in those Kaggle environments. What do they use under the hood? They will have to isolate systems, right? So definitely, Kaggle is a big, big consumer of Docker systems, right? So if Kaggle is one of the pioneers of using Docker containers when it comes to reproducing machine learning architectures, who are we not to adopt it, right? So mostly this stuff is a confluence on the DevOps part and the data science part. And now we have talked about a little of both the worlds, right? So with Python at its center, we talked about Dockers, and we talked a little about data science. and how important it is to reproduce data science outputs, right? So with that in mind, this is a term that I'm going to coin. I'll start calling this analytics ops, right? So we want to go from machine learning being a lab experiment to something that can actually be operationalized, right? So even if you have an algorithm that knows the meaning of life, for all I know, can users interact with it? Is the only question that bothers me, right? So in order to deploy your machine learning applications, you'll need DevOps, or you'll need significant knowledge of DevOps to take that forward. And that's where Dockers come in as a cutting edge piece of technology, an advancement over virtual machines, okay? So it's basically about making that framework which makes analytics digestible. So ultimately, all the analytics that you're going to do, whether it's about building a dashboard, or it's about building a search engine, building a clustering service, everything that you'll do machine learning will ultimately need to hit an end user, right? An end user has to talk to it in some way, using a web application or using a mobile application. There has to be some user interface that has to come in front of a non-analytics guy to leverage all the good stuff that you have built, right? So it provides you that framework which makes your machine learning models very digestible.